Hey everyone, I'm Vay and I have just finished my third year of material science and engineering, and today I will be taking the Instagram over to talk about my co-op position here at the CAMC at Mark. Tell you guys a little bit more about the CAMC. It is the Center for Automotive Materials and Corrosion. So here we look at a lot of steels that have to do with automotive applications. Specifically for my summer co-op, we're looking at third generational advanced high strength steels, and specifically for me, we're looking at the bending of those materials. So I'll take you guys on what a day in my life looks like here at the CAMC. So here I am now in the sample prep room to actually show you guys what I've been working on. So I'm working under Daniela Poliska, which is one of the PhD students. Many of us know her and love her from TA to BO3 with Dr. Zarab. And under her, I'm working under her specific steel grade out of a bunch that they're working with for this specific group. So here we're working with steel H, which is a medium manganese steel, and it has a certain composition that is different to steel A, B, C, D, all the way to H. In order to be able to test these steels, first we take a panel that looks like this, and it is annealed at 690 degrees for 60 seconds. So there was 3 of these, and then we sectioned out the heat affected zone. So here is where we'll get the best results out of anywhere in the panel. That way we can measure what's going on in each section of the panel and whether it'll be different or the same. After having the panel and all of it marked out, then we cut all of these strips out and then cut it right in half. And then we're left with these samples. So now we're left with a bunch of these little strips, and they look like they've been spray painted with a bunch of little dots because they have. So that's for DIC, which is digital image correlation, and that is used for testing tensile strain. So we get a good map of what it looks like when the highest tensile strain occurs, and we get a good image of a lot of more information than we can just from doing a normal test with the naked eye. So now that we have a bunch of these samples, as you can see, then we perform the bending test on them. So then they end up looking like this, and all the samples might have different or variations of the punch radius and at different angles, just to see how they would react and whether they would fracture, which we usually can see the fracture on this side of the sample. And then of course I mounted them, and we get something beautiful that looks like this. And then just to get a good image in the cross section of the sample, we like to cut it on the precision cutter over there. And then so we get a nice cross section. Now it comes out looking like this, but a little bit more rough. So then we do some grinding on the automatic polisher, some grinding, polishing, and as well as etching to get a good look at the microstructure. Now we're on the key-ins, and here you can see the up close image of the fracture, and you can also see a bit of the microstructure as well behind it. So now we get to take really great pictures of what the fracture looks like. We can measure it if we'd like. And yeah, now after doing this for all 10 samples, now we can get a good image of what the fracture surface looks like and what the tensile strain will produce within the material. We can make any conclusions, do any more tests, and then that's what research looks like here at the CAMC. At the CAMC brings such a great atmosphere with everyone that works here, everyone being so helpful, and also knowing them since I've had the most of them, the people that work here as TAs for different classes. So everyone's super helpful and knowledgeable. Literally, you can't go a day without learning something new here, and you get to do a little bit of something different every day, whether it be helping someone else with a task as well as doing your own research. And you get to get trained on really cool equipment like the key-ins, and do some SEM training and other training at other facilities as well, which is really awesome. I've worked here 2 summers now. This would be my 2nd summer, but since last summer COVID got a little bit in the way, this is my 1st summer really doing some awesome research and getting to know everyone. So I just love it here. It's super awesome. So if you ever get a chance to do research at the CAMC, highly recommend. And when I'm not here at the lab, I'll be at home working from there on the computer, doing some research, making notes and graphing stuff. Since I know some of you might be curious how to get a research position here at the CAMC for the summer as a co-op student, I literally just emailed Dr. McDermott, or you can email anyone that works here at the CAMC and see if they would like to take you on as a summer student. You know, I just expressed my passion. So I emailed him in the December before the summer, and he saw that I was excited about it and loved steel, of course. and then I got hired on here. So let me know if you guys have any more questions about what I can show you here at the CAMC while I'm here, and as well as how to get a co-op or any general questions about materials engineering. Thanks for listening.